In part 3, we'll talk about other components of the skeletal system, and these are joints, ligaments, and tendons. Joints are the structures that connect the bones, and we can classify them by how much movement they allow. And there might be almost no movement. Like I showed you, the bones of the skull are connected, but they're so tightly connected that you cannot almost see the separate bones. And definitely there is no movement in this case. Then there might be slight movement, like for example, between the vertebrae, and the joints will be here provided by the invertebral discs, or there can be free movement of the bones along each other. And this is also related to what type of tissue binds these joints. So the joints, usually the joints that move very little, are connected by fibers, like by connective tissue rich in collagen fibers. Like here, for example, the same sutures of the skull that I just mentioned, or for example, our ulna and radius in the arm are connected very tightly, and there's almost no movement. Then cartilaginous joints connected by cartilage, as invertebral discs made of cartilage, or here the hip bones are connected by the pubic symphysis. Very little movements. There is a movement, some, but very little. But we are most interested in the synovial joints. And these joints are very different because, or they're also called freely moving joints, because the joints, the bones are not bound to each other. They are separated by the cavity, and this is called joint cavity, which is filled with the fluid, synovial fluid, which definitely lubricates the joint, the movement, and facilitates the movement of the bones. Moreover, the bones themselves, the ends of the bones that come in contact, they are covered with the cartilage. Articular cartilage, which means articular means it's in the joint. And cartilage is a very smooth and slick kind of tissue, and that helps joints to move, kind of glide over each other with little friction. So the movement is very easy and free. All structure, all this type of joint is surrounded by the capsule that keeps the bones together, plus it seals the synovial joint in it. And these kind of joints are supplied by a lot of blood vessels, and they also have a lot of nerve endings, which helps the brain to detect the movement, to detect the stretch of the joint and positioning of the joint. So a lot of blood vessels, a lot of nerve endings, except cartilage, except this part of the joint, because cartilage is a very interesting type and very unique type of tissue. It's a connective tissue, and it doesn't contain blood vessels or nerves. If you look at the structure of connective tissue, you will see cells, separate cells, sitting here. They're called chondrocytes. They're sitting in little spaces called lacunae also. And they produce a lot of matrix, and this matrix is kind of gel-like or rubber-like. And that means it works very well for the, first of all, it's slick, it slides, and also it also works very well for the shock absorption. And that's what connects what allows the connection between the bones, the joint, to move freely around each other. The other unique component of the freely moving joint or synovial joint is synovial fluid itself. So it's here. Let me show you. So this was our cartilage on the top of the bones and synovial fluid between them. So first of all, it lubricates the joints, and the more joint works, the higher is the activity, the more movement is in the joint. That increases the friction, and friction always results in the heat generation. But when the synovial fluid, when the temperature of the synovial fluid increases, that reduces its viscosity. So it becomes thinner and that allows for better lubrication, and that allows for better joint movement. So that's one of the functions of the synovial fluid. The other one is its unique property. Its synovial fluid is sometimes called non-Newtonian fluid, which means that its viscosity depends on the force that applied to this fluid. So in other words, when there is a shock, when there is a shear force that applied to the knee, not to the knee, to the joint, to the synovial joint, the synovial fluid becomes thicker, and it becomes something like it provides the shock absorption. So if you jump and hit the ground at this moment, your synovial fluid becomes very viscous and protects your bones from hitting each other, or protects your cartilage from breaking. And then once this force is gone, it becomes liquid again, less viscous again, and now it works as a lubricant. And the last function of synovial fluid, it supplies oxygen and nutrients to the cartilage, because as I said, cartilage doesn't have the blood vessels or the nerves. The movement that synovial joints allow depends on the type of the joints. And here I show you 6 types of joints. I'm not asking you to learn them, just wanted to demonstrate you the array of possibilities of movement provided by the joints. So for example, we have pivot joint. And I love it because it's like joints almost work like some machines, some mechanisms. You see, we have the pivot joint that works in the spine, the first vertebrae of the spine, C1 and C2, cervical vertebrae. And this joint allows the head to turn to the sides. Or we have the hinge joint with 1 degree of freedom of movement, and that's one in your elbow. Or we can have the saddle joint, which has 2 degrees of freedom of movement, and that is in your wrist. Or there are also pling joints, and this is more like a gliding movement, and you can find it in your ankles. And then we have condyloid joint in the wrists, which gives you a pretty big range of movement. But the ones that give you a lot of freedom of movement, that's ball and socket joint. We only have 4 of them in the body, and humans have, we have 2 in the hip joints and 2 in the shoulder joints. And you can really move your arms in many, many directions because of this type of joint. And now let's talk about a little bit ligaments and tendons. And you have to know the difference between ligaments and tendons. So ligaments connect bone to bone, and they support the joints, and in a way they limit their movement. So they allow joints to move in a very particular direction. An example of ligament will be ACL. I'm pretty sure everyone heard about ACL because it's one of the most commonly damaged ligaments in a human body. So what it does, the knee has 4 major ligaments. ACL is one of them. They connect the thigh bone to the shin bone, and they stabilize the knee joint. And unfortunately, when there's somebody kicks the knee from the outside, what can happen is called unhappy triad of knee injuries. The torn ACL, then another ligament is also torn. It's the medial MCL, medial collateral ligament, and the meniscus. This is a C-shaped cartilage that's present in the knee, is also torn. So very common injury and takes a lot of time to repair. Tendons, they are also stretches of connective tissue, fibrous connective tissue, very similar to ligaments, but tendons, they connect muscles to bones. Without the tendons, the muscles won't be able to move the bones. So they transmit the force of the muscle contraction to the skeletal system. They are not, even if they're located like around the joints, they are not considered the part of the joints. And some people don't even consider them part of the skeletal system, but again, I think they are. So the examples of the joints will be, for example, Achilles tendon. It's the largest tendon in the body. It's attaches the calf muscles to the heel bone, and it's absolutely essential for the people to be able to walk. Like, for example, in ancient, I think it was in ancient Greece, one of the punishment for the slaves was to cut the Achilles tendons and just to leave them, and these people became completely defenseless and unable to move and died. It's a very cruel punishment. And that's it on bones, on joints and ligaments and tendons. So we'll continue with some bone and joint pathologies.